Myself, Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering College. In this session, I am going to discuss about electrochemical series and its applications. In this session, I am going to discuss about electrochemical series and applications of electrochemical series. So, the electrode potentials of different electrodes can be found using standard hydrogen electrode and other reference electrodes. The electrode potentials of different electrodes can be found by using reference electrodes, primary reference electrode and secondary reference electrode. Primary reference electrode is hydrogen electrode. Secondary reference electrodes are saturated calomel electrode and silver chloride electrodes. So we can measure the electrode potentials of different electrodes by using reference electrodes. So if we found the electrode potentials using standard hydrogen electrode, the potential of a standard hydrogen electrode is assumed as 0 volts. So the measured EMF itself is the standard electrode potential of that electrode. Standard electrode potential of that electrode. So like this, first we have to measure the electrode potentials of different electrodes by using standard electrode potentials, and they have arranged these electrode potential in ascending order or descending order. That series is called as electrochemical series. What is electrochemical series? The arrangement of electrode potentials of different electrodes from highest negative to highest positive means ascending order, or highest positive to highest negative means descending order, is called as electrochemical series. The arrangement of electrode potentials of different electrodes from the highest negative to highest positive or highest positive to highest negative. So that series is called as electrochemical series. This also called as activity series. The electrochemical series also called as activity series. So this is the electrochemical series. In this, standard electrode potentials of different electrodes are measured and they are arranged in the descending order. Here I am taking the descending order. Electrochemical series means the electrode potentials of electrodes are highest positive to high positive to high negative. Here this is high negative charge, this is high positive charge. So here they have arranged the electrode potentials of different electrodes in the descending order, means highest positive charge to highest negative value of electrode potentials. So in this, the hydrogen, the standard reduction potential of hydrogen is 0, and below this hydrogen electrode, so we will observe the negative values increasing, above this positive values increasing. Above this positive values are increasing, below this negative values are increasing. So this is the electrochemical series. So applications of electrochemical series. So first application is checking the feasibility of the cell reaction. Checking the feasibility of cell reaction. Second one is reactivity of metals. Second one is reactivity of metals. Third one is the pattern of displacement reactions. The pattern of displacement reactions. So fourth one is reducing nature of metals. Also we can measure oxidizing nature of non-metals, thermal stability of metal oxides and product of electrolysis, and also calculation of standard EMF of electrochemical cell. Calculation of standard EMF, that is E0 of electrochemical cell. So these are the applications of electrochemical series. So we will understand one by one. So first one is checking the feasibility of a cell reaction. checking the feasibility of cell reaction. So under the standard, we know that under the standard state, delta G equal to minus NFE naught. Minus NFE naught. If EMF is positive, if EMF is positive, means if we substitute these positive values in this equation, so what we will get negative value. So negative value means if EMF is positive, delta is negative. So when the reaction is spontaneous. So EMF is positive, delta G is negative. Means that reaction is called as spontaneous reaction. Spontaneous reaction. If EMF is negative, if we substitute negative value in this, so negative, so we will get positive, means positive NF. So delta G value is positive. This type of reactions are called as non-spontaneous. Non-spontaneous reactions. If delta G is EMF is positive, that reaction is spontaneous. If EMF is negative, that reaction is non-spontaneous. That reaction is non-spontaneous. If EMF is 0, so what will happen? If we substitute in this equation, we will get 0. Delta G also 0. This indicates the equilibrium condition of reaction. Equilibrium condition of reaction. Equilibrium condition of reaction. If EMF is 0, delta G is 0, which is the condition of equilibrium. So finally, we can tell that. So if EMF is positive, that is spontaneous reaction. If EMF is negative, that is non-spontaneous reaction. If EMF equal to 0, so that is said to be equilibrium. That reaction is in equilibrium. So, for example, a chemical reaction is feasible if the EMF is positive in that particular direction. Otherwise, the reaction won't be viable. So, this is the one example. In this, we have taken zinc in zinc sulfate, copper sulfate in copper sulfate. So, this is one electrochemical cell. So, EMF of this electrochemical cell is plus 1.10 volt. Plus 1.10 volt means here the EMF equal to positive. So, that this reaction is spontaneous reaction. This reaction is feasible reaction. So, if we take reverse, means copper sulfate in copper sulfate, zinc in zinc sulfate. If we take that electrochemical cell, so the EMF of this cell is minus 1.10. So, here E equal to negative. So, this is non-spontaneous reaction. So, from the values of E, it can be seen that zinc can reduce the copper. But copper cannot reduce the zinc. It means this second reaction is not feasible. First reaction is feasible reaction according to the EMF calculations. So, next one is reactivity of metals. Metals are reactive if they lose electrons easily. Means the tendency to form cations. So, those metals with high negative value, Those metals with high negative electrode potential value are smaller positive value of standard reduction potential lose electron quickly and are highly reactive. So metals which are having high negative value, metals which are having high negative reduction potential values, or the metals which are having low positive values of reduction potentials. So they are reactive. They are reactive. Means if we see the electrochemical series, here from the top to bottom, the negative values are increasing. The negative value of electrode potentials of different electrodes are increasing. The negative value is increasing. Means here 0.13, here minus 3.04, means negative value is increasing. So that means this lithium is having highly reactive. This lithium is highly reactive than sodium. Sodium is highly reactive than magnesium. So we can say that if we take two metals, I am taking lithium plus and sodium plus and magnesium plus 2 ions. In this, which is reactive means lithium is having higher negative reaction potential. So that's why lithium plus is having high reactivity than sodium plus and magnesium plus 2. And also sodium plus is having high reactivity than magnesium plus 2. So this is the explanation about reactivity of metals. So examples of these reactive metals, group 1 and group 2. Group 1 and group 2 metals have high negative reduction potential. Therefore, they can easily dissolve in acids. They can easily dissolve in acids. The reactivity of metals can be also studied as the electropositive nature of elements. Electropositive nature of elements. Here, this lithium is first group element and also sodium also first group element. This magnesium is second group elements. So these three are having high reactivity among all the metals which are present in electrochemical series. So these reactivity of metals can also be studied as the electropositive nature of elements. Electropositive nature of elements. So just like metals, it decreases as the value of reduction potential increases. So the reactivity decreases as the value of reduction potential increases. As the value of reduction potential increases. So it can be studied with the following division. First one is strongly electropositive, moderately electropositive, weakly electropositive. Strongly electropositive metals have standard reduction potential around the minus 2.02 and more negative. Minus 2.02 more negative. Means here we are having three elements. So three metals. So these are strongly electropositive metals in the electrochemical series. So lithium plus, sodium plus and magnesium plus 2 are strongly electropositive metals because these are having around minus 2.02 more negative value. So moderately electropositive metals have standard reduction potentials between 0.0 to minus 2.0. So minus 0. Here from this. So these are moderately positive. These are moderately positive metal ions. Moderately. These are strongly. So weakly electropositive metals are placed above the hydrogen and have positive reduction potential values. So remaining all are weakly electropositive. Weakly electropositive. So between 2.0 to about 2.0 volts. So these are strongly electropositive. These above 2.0, in between 0 and 2.0 minus 2.0, these are moderately electropositive, and above 0, so these are weakly electropositive. So this is about the reactivity of metals. So third one is the pattern of displacement reactions. The pattern of displacement reactions. A metal lower in the electrochemical series. The metal lower in the electrochemical series can displace metal from its solution. The metal lower in the electrochemical series will displace metal from its solution. Means which is higher in the series. The higher negative value of standard reduction potential, and the more be its tendency to displace another metal. The more be its tendency to displace metal. So this zinc metal is capable of displace the copper copper metal from its salt solution. So this is having lower value than this one. So copper is having higher value, higher reduction potential value. So zinc is having lower reduction potential value. So that's why this zinc plus 2 is capable of displace the metal ion of metal ion means that copper ion from its copper sulfate solution or its salt solution. So this is the example. So in this, zinc is displaces the copper from its salt solution. What is salt solution? This is copper sulfate solution. Copper sulfate solution. It is displacing from its salt solution, and it is forming metal. So this is undergoing oxidation and this is undergoing reduction. So reducing nature of metals. Reducing nature of metal. The reducing nature of metals depends on the tendency of losing electrons. Reducing nature of metals depends on the tendency of losing electrons. So the higher the negative reduction potential value, the higher the negative reduction potential value. Negative. So the more is the tendency to lose electrons. The more is the tendency to lose electrons. So their reducing nature decreases as move from lithium to fluorine in the electrochemical series. Hence we can say that lithium is the strongest reducing agent, and fluorine is the weakest reducing agent. So the reducing nature of the metals depends on the tendency of losing electrons. Reducing nature of metals. Reducing nature of metal means it should reduce another metal. It should reduce another metal. So it should undergo oxidation. It should undergo oxidation. So it should have a tendency of losing electrons. Then only it can give the electrons to the other metal and it will reduce that metal. So the higher the negative value of reduction potential in the electrochemical series, so the more the tendency of lose electrons. The more the tendency of lose electrons. If we see the electrochemical series, here negative value is increasing. So lithium is having higher negative reduction value. That's why this is the strongest reducing agent in the electrochemical series and among all the metals. So the reducing nature decreases from the, if we move from lithium to fluorine, reducing nature decreases. Reducing nature decreases. If we move from bottom to top, bottom to top, reducing nature decreases. Decreases from lithium to fluorine. from lithium to fluorine. Next one is oxidizing nature of non-metals. Oxidizing nature of non-metals. So, more is the reduction potential value, higher is the tendency of accept electrons. It is reverse to the reducing nature of metals. So, in that case, we are having higher negative value. In this, we are having higher positive value. Higher is the potential value, means higher positive or positive reduction potential or higher reduction potential. Higher reduction potential. So, oxidizing nature of metals depends on the tendency of accepting electrons. Depending on the metals, on the tendency of accepting electrons. Means the metal should undergo reduction. Metal should undergo reduction and it should reduce, it should oxidize another metal. It should oxidize another metal. Another metal oxidation will take place in presence of this type of metals. So, more is the reduction potential value, higher is the tendency of accept electrons. Thus, oxidizing nature decreases from top to bottom in the electrochemical cell. So, if we see the values of reduction potentials, here values are decreasing. Here, this fluorine is having highest reduction potential, lithium is having lowest reduction potential value. So, this fluorine is having higher oxidizing nature, highest oxidizing nature in the electrochemical series. So, hence we can say that fluorine is the stronger oxidizing oxidant than chlorine. So, here chlorine is having 1.36, fluorine is having 2.87. So, if we take fluorine and chlorine, if we take fluorine, chlorine, so we can say that fluorine is the strongest oxidizing agent than chlorine because it is having lower reduction potentials than fluorine. So that's why fluorine is the strongest oxidizing agent than chlorine. So sixth one is thermal stability of metal oxides. Thermal stability of metal oxides. The thermal stability refers to the stability of metal oxides at high temperatures and it depends on the electropositive nature of metals. Electropositive nature of metals. The electropositive nature of metals increases from top to bottom and therefore thermal stability also increases from the top to bottom. So we know that, so these are having higher electropositive nature in the electrochemical series. So from the top to bottom, if we observe that, so electronegative potentials are decreasing. So the reduction potentials are decreasing. Reduction potentials decreasing means, so the electropositive nature of metal is increasing. Electropositive nature of metals increasing. From this electropositive nature of metal increasing. So that's why the thermal stability increases. Thermal stability increases. Electropositive nature increases and thermal stability increases. So the electropositive nature of metals increases from the top to bottom and the thermal stability also increases from the top to bottom. This is about thermal stability of metallic oxides. The seventh application of electrochemical series is product of electrolysis. Product of electrolysis. If we take two or more types of ions, if we choose two or more ions present in the solution, they are liberated at the electrode according to their preference during electrolysis. According to their preference during electrolysis. The cations having high value of standard reduction potential are discharged first at cathode. The anion with low standard reduction potential value is liberated first at anode. If we take cation, it should have highest value reduction potential. If we take anion, it should have low standard reduction potential. So the cation which is having highest standard reduction potential, first it will discharge first. The anion with low standard reduction potential, it will liberated first at anode. So it will liberated at anode anion. This will accumulated or deposited on cathode. So this is the example when an aqueous solution of copper sulfate containing copper plus 2 and sulfur minus 2 and also H plus OH minus ions. If we take copper sulfate solution, aqueous solution, means we are adding water. Means if take this solution, we are having copper plus 2, SO4 minus 2 ion and also H plus and OH minus ions. So in this we are having 2 cations and 2 anions. So which cation is deposited on cathode? Means this is copper plus 2 is having higher reduction potential. So that's why the copper plus 2 is deposited on the cathode first. In the anions, which is liberated means the OH ions, OH minus ions move towards the anode. Because it is having lower reduction potential. So the cations should have highest reduction potentials, anions should have lowest reduction potentials. So final one is calculation of standard EMF of electrochemical cell. Calculation of standard EMF means E0 of electrochemical cell. The standard EMF of the cell is the sum of standard reduction potential of two half cells. Reduction half cell and oxidation half cell. We know this, having two half cells and these are connected to voltmeter. So if we measure the EMF of the cell, this is the first half cell, this is the second half cell. E cell equal to, we know this, E reduction potential of cathode plus oxidation potential of anode. So we know that the oxidation E0 oxidation equal to minus standard reduction potential of E reduction. So means E oxidation equal to minus E0 reduction. Standard reduction potential of E reduction. So we can write as E cell equal to E cathode minus E anode. So we know that the formula of E cell equal to E cathode minus E anode. So this can be explained by this example. In this 2 Ag plus Cd cadmium gives rise to 2 Ag plus Cd plus 2. This is one reaction. So they have given standard reduction potential of silver plus in silver and cadmium plus 2 in cadmium. So these are 0.80, and for cadmium reduction potential is 0.40 volt. So from this we can say that from this equation here what is happening, Ag plus is converting into Ag, means here reduction is taking place. Reduction is taking place. Cadmium is converted into cadmium plus 2, means here oxidation is taking place. Oxidation is taking place means it is acts as anode, it will act as cathode. It will act as cathode. So we know the reduction potential of cathode and anode. So by substituting these values, so E cathode means minus 0.80 minus of minus 0.40. So we will get 1.20 volts. 1.20 volts. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.